Hello, good evening, everyone. Are you able to hear me? Okay. Is everyone able to hear me? Can you just type yes in the chat box? Okay. So let's get started where we left off last time. So I'm hoping everyone had a chance to go through these slides, and I sent out a link for the YouTube video. And if you have not gone through that, after this session, just go through the first session. It's very, very important just to get started on R and R Studio. And today we are going to do more practice and dive deeper into our basics and arithmetics, and today's topic is vectors. But let's finish off the one apart from last session, and I need everyone to, like, right after the sessions, I'm allowing a few days time just for you to practice on your own. Even if you're doing it on the session, I would highly encourage everyone to practice it on your own, since the feel of programming only comes when you do it on your own. So the more and more practice you do, the more confident you'll get in programming. So I would highly encourage everyone to practice whatever is on the slides. If you need more practice examples, just ping me or email me. I'll send them over to you. And by the end of this course, my goal is for everybody to be at least intermediate level programmers. And I may have a couple of tests if people are interested in doing that, just to update your skills, just to have everything in your mind at once, because every session after session you just do it and you forget it. So it's very important to have one test, maybe once in the mid course and one final, just to have everything, review everything at once and do it. So it might be open book, so you are free to you would be free to use the internet. The whole goal of this is to be able to develop those skills of programming. So in programming, like in our everyday jobs, we never learn anything by heart. We always just remember the what to do, and we just know what to type in Google just to find out what that functions are. But some of the functions we know them because of years of programming, but as beginners you may have to look up everything, pretty much everything. So if people are interested, maybe I can send out an email regarding that, and we'll have one test mid of the course, like after 6 sessions, and then we might have one at the end. Oh, you don't hear my voice? Just 1 second. Let me see. How about now? Can you hear my voice? I think it was Venkat. Venkat, can you hear my voice? Is it just Venkat's problem or everybody's problem? Um, so you might, Venkat, you. So is everybody else able to hear my voice? Can you just type yes in the chat window? Okay, good. Okay, so I think it's just fine. Good. Okay. Okay, guys, I want you to mute your microphones, which is there in the audio part of the menu, because I can hear. Yeah, now it's okay. So everybody mute your microphones. Only if you have a question to ask, just unmute it and ask the question. Okay, good. So everybody is able to hear. Sorry about that. Um, so let's dive deeper into where we left off last session. If you remember, we left off at this empty cars data set, which is an inbuilt data set for R, and it ships with the R installation and R Studio installation. So last time I would just try to um, do it once again. So if you remember, the function str gives the structure of any vector or any data structure. So if we do str empty cars, you will actually get what it contains, and we will go deeper into what this structure means and what each of these mean. But for now, str gives you a function. Str is a function that actually gives you the structure of any data set. So right now we are dealing with empty cars data set, and this data set, if you actually want to look at how this data set looks, you could use head of that particular data set. And if I do head of empty cars, you can actually see there are these column names, mpg, cylinders, I don't know what that is, but HP and things like that, weight and things like that. And then on the rows, you have the different cars and models. And for each row, for that particular car and model, you have these particular numbers. Each have their own values. So this is the data set that we'll be looking at for our next page of commands. So these are very simple commands, but it's it's helpful for you to pause and at least try out one command here. Um, so there are different parts in this command. Suppose if you want to look at the very first command, max. Max is a command which picks the maximum value of um, of of whatever column you choose. So here what I'm doing is empty cars. The dollar symbol starts means that you're picking one particular column in that data structure. So empty cars has a column name mpg. If you want to look at what column names, once you get a data set, if you want to look at what column names that particular data set has, you could type column names of function, and you can use the empty cars, and it lists out all the column names in that particular data set. So so what we have here is the 11 columns we have for this particular data set, and it gives so if we want to access any particular column, we have to give it as a dollar sign, because this is a data frame. I'll come back to what data structures R has in a little bit, not today, but we'll in the future sessions. But for today, let's remember that this particular data set, empty cars, is a data frame, and so each column can be accessed by the symbol dollar. And as you can see in RStudio, it's actually automatic. So whenever you type empty cars dollar, you see all the columns listed over here that that particular data set has. So even if you have bigger column names, like first name, last name, or name, address. Even if it's bigger than that, maybe it's like 128 characters. So you don't have to type out each and every column name. You could just pick that particular, double click on that, and then it will pick that column name for you. So if you want to see what this actually brings out, you can type emptycars.mpg, and it will list this particular column if you want to check. So head just gives us the top six rows, but this is there is a whole lot of rows. Empty cars is much bigger than that. That's why when we have like a dollar mpg, it's giving the full values contained in mpg column. If you want to try to see what the dimension of this data set is, you have to do it as dim, dim, empty cars. Then you will know how many rows there are and how many columns there are. So dim of a particular data set returns two values. So the first value stands for the number of rows. So what it means is empty cars data set has 32 rows within the data set, and has 11 columns. 11 columns, you can actually count it here. There are 11 columns. So that's one thing we can see, but the rows, we cannot see it in head, the full rows. But you can as well, if it is a tiny, this is a tiny data set which is 32 rows. So you could actually go into environment and just see, just let me get to get the particular data set, you have to type it with as data empty cars, then the data set will be stored in your environment. If you go to your environment, double click on the empty cars, it actually doesn't work. Just 1 second. If you can actually type it over here on your console, empty cars. Okay, now it works. You could double click on the data, and it opens up another tab over here, just displaying the whole data set. This is only, again, there is a caution here. This is only if the data set is small, that is maybe up to a few thousands or even hundreds or even a few thousands. But if the data set is too large, suppose if you have like 50,000, 60,000 rows, it's going to display only, I think about 10,000 or so is the limit, based on what your RAM is and how much is allotted for RStudio. So because this is a tiny data set, which is only 32 rows, it printed out everything over here. So if you can actually physically look at what the data is over here. Or if you want to print it on your console, just do empty cars over here, and it prints out everything. So you could just look at the whole data sets. But mostly, like practically, what we deal with is larger data sets, having more than maybe 100 rows or even more. So what we do generally, just to get an idea, is just to head of that particular data set. And that's what the very first 6 lines are displayed, and that is good enough for us. And if you want to look at the dimensions of the data set, you do the dim of data set. So that gives you the very first number is the rows, and the next one is the number of columns. So let's look at the first example. I'm not going to go into each and every example on this page, but let's try out just a few. If you do a max, which is the maximum value, you could pick anything. Again, I told you that you have to pick a particular column, right? How will you know? Otherwise, how will you, if you pick the whole data set, I think it's going to choose the entire data set and pick a maximum value out of it, which doesn't really make sense, and it's not very helpful in practical terms. So if you want to pick the maximum MPG providing car, then you do a max of that particular column, then it gives you that 33.9 is the maximum MPG for the data set that we have, empty cars. And so there is another parameter over here. If you look at this, there is a parameter called na.rm equals true. So what na.rm means is that there might be some values which are not present. Maybe they weren't able to record it, or maybe some are not available. So what we are asking this function to do is we are saying remove all those non-available values. So there is one parameter. So if you want to, for any for how so one question, like thinking of it, if looking at it as a first timer, right? What I feel is, how will you even know what parameters you have for every function, right? So that is where this help comes in. So if you remember last time, I told you that you could type any functions over here, and the R will pull up our documentation from here. So you could type here max and see what R pulls up. So here you have the usage, right? So it pulls up something. Let me just maximize this window. It pulls up our documentation, and it says it's maxima and minima, and it describes the function, and it describes the usage. And from this usage, you will know what parameters there are within each function. So you don't have to really remember anything. You can just type it in the R help over here in our studio. And so last time I forgot to tell you one thing. Whenever there are functions that you have in the R help documentation, if you scroll down to the bottom of the page, you have some examples over here. So of course, this is a very simple function, but you will get into complicated functions and you will not know what it returns. There are a bunch of examples for every function. R has a bunch of examples over on the bottom of the page if you scroll down to the bottom of the page. So these examples, you could directly take this and copy and paste it in your console, and it will run for you. So right now I just copy pasted all that code that's there as examples in the R help documentation, and it's going to run it. But you don't get panic looking at all these plots right now. But the purpose of this is just to tell you that there are examples there are examples for every R function. And if you want to know in detail what it means, how to use it, suppose for this R function, right? So is there a max in this? Okay, so max is not there, but min is there. So min is there, and it's asking us what's the minimum value for a sequence of numbers from 5 to 1. So if you remember last time, I told you you could use you could use this colon operator to print a sequence of numbers. Suppose I have this numbers from one. If I want to print out 125, it's going to I could use a colon, and I could print every one of those sequence of numbers. So similarly, you could do the reverse. You could give it as 5 to 1, and it's going to print a sequence of the numbers. So just reminding you of that one. But let's go back to our slides. So max, as I just told you, it prints out the maximum value for whatever column you choose. And to remove the non-available values, you could use this parameter na.remove equals true. And if you don't know what parameters, and nobody can ever remember what all parameters every function has, so you go back into the documentation, look at the usage and what parameters have. This is actually a very simple function. That's why it's giving you right over here. But for many other complicated functions where there are more than one parameters, this documentation is going to display each and every one and give what it has by default and what you can change it to. So depend on our documentation for every function if you have any questions. So likewise, you could just go through this page, run each and every of these commands on your own, and type it in the R documentation. So that is an exercise for you. Type it in the R documentation for minimum, for the mean, median, sum, variance, standard deviation. This is, I think it's mean average or mean arithmetic deviation. I think that is it, but you could, so as you could just type it over here and check. Mean absolute deviation. So that's the documentation for mean absolute deviation. So just now, as I was telling you, there's look at this. There are more than one parameters, and nobody can ever remember all these parameters. If you look at this, the argument section, it's giving you in detail what these parameters actually mean. So you could say if you want to calculate the mean absolute deviation of any particular vector. Let's do this, just this example. I don't want you to panic by looking at all these new functions. So I want to just show you just doing the MAD function. Suppose if you have, let's make X as, a series of numbers from 1 to 5, right? Or you could just have X as, or the one of the column from the empty cars, right? MPG. So X right now has all the MPG values from empty cars. So let's run MAD, mean absolute deviation of X, and see what it returns. It returns a particular value, which is the absolute mean, absolute median, absolute deviation value. Sorry, I was all this time I was saying mean, but it's, sorry, median absolute deviation. Median absolute deviation of this particular vector. So it may be anything. Suppose I want to, suppose if there were NA values in this, I would have used NA dot remove equals true over here. If you can look at the usage of this, there is already a parameter called NA dot remove equals true. Since this vector doesn't have any NAs, which is non-available values, that's why I didn't use that parameter. But if there were any NAs, to remove it from our calculation, we would remove the NAs. So if you just slightly try to recollect your stats or your math, if you have any values that are not available or zeros, it puts off your arithmetic mean median calculations. So that's why it's very important to remove them from our calculations and calculate just for the ones which are actually recorded and remove the ones which are not available. So that's what median absolute deviation is. And five num, I will actually give this to you to find out what that is, to type it in the help and let me know next time. So let's move on to our session 2. So in today's session, we'll mostly focus on the vectors and what operations you can carry out on those vectors. So the first one is, so this slide just talks about arithmetic operations. All basic arithmetic operations are supported. Like last time, if you may be reminded of the basic operations, you could just do it over here on the console. If you want to add certain numbers, sorry, I had a dollar sign in there. If you want to add or subtract, multiply, divide, any basic operations can be run over here. And the second point, what it means, all arithmetic operations, operators are vectorized. It means that whatever, let me close this one. It means that whatever the value that is returned from any operation, it is a vector. I'll just in a moment, I'll tell you what vector is, and by the end of the session, you'll be clear with vectorized data structure. So if you remember from the basic of maths, we had something called as Bodmer's rule. Excuse me. Bodmer's rule for carrying out operations, arithmetic operations, and the order they have to follow when there are multiple operations in one single command. Right. So this is the same thing that you in Bodmer's principle, you have brackets come first, and then there is of, and then division, multiplication, addition, and subtraction. So just using that BODMAS principle, every arithmetic command comes with the order of the or the sequence of operations that are carried out, and these are the classic rules. Exponentiation comes first, then comes multiplication, division, addition, and subtraction, and you can change any of these or any of the precedents of the operations using a parenthesis. So it's just basic math stuff. And so this is something that this slide, I have it here because you could run any mathematical functions using this. So I have a list of all the mathematical, not all, most of the common ones that you would use in research or any of your daily calculations. And I would just go through some of this, but I would highly encourage you to practice some of these in your R studio. So the first one is absolute value of x. Absolute value is just if it is a negative or a positive, it always returns the absolute value, which is the positive number. And log of x base y. So as you know, logarithmic values we could have to the base e, to the base 10, to the base 2. So this is one function which takes care of different bases, and you could provide the number. So x is where you provide the number. So just to show you one example of this, I'll show you if I want to do a log 10 base 2. That's how I do it. So you could change the base to anything. Log, mostly they have a log, we use log 2 and log 10, or there is another function log 2 of 10. So you could just save some code by missing out on this and just adding the 2 over here. And exponential of x, x sqrt, square root of x, factorial of x, x factorial, and choose x and y if you try to recollect some of your probability and statistics. Probability, you have NCP, which is you suppose if it's 3C2, you have different combinations of the values of 3. So you could use this function to do that. You would not very frequently use all this, but it's good to know that it's there. Maybe this one you'll probably frequently use it, because p-values should be rounded to two digits, decimals, or even smaller than that. So round off function, and you could specify the number of digits you want. Floor off, ceiling off, and significant digits. So all these, I have a list of them here. I highly encourage you to practice this after the session. So let me just have it in the full screen mode so people can. So I would just pause here a little bit and see if people have any questions. Any questions, please type into the chat window. Any questions so far? Okay. So let's continue with the next slide. All right. So here we enter into this this part of most important part of today's session, as well as you will use vectors throughout our programming, and knowing what a vector is very important. So any data structure, as I told you at the beginning of today's class, that you could use this function str to find out what the type of data structure it is. And if you use this function, it always returns a type vector. and you will see in a bit what this exactly means. So, and instead of this, I could just show you with the example once again. If I do the structure of empty cars, right, you you look at it as this result. The very first line calls it a data frame with 32 observations and 11 variables. Again, variables is a column names. And so there are 11 columns and there are 32 rows. And if we look at, so what the structure gives is it gives you each column name, and it's going to give you what that column type is. It's a numeric, NUM here means it's a numeric column, and it displays some of those values from the top. This, it does it for every column. So this structure value and this type, whatever it returns, this structure function returns is a vector. And we'll have some more examples to clarify to you what a vector actually means. It's just a data structure, and how the data structure will be explained in the next few slides. So it returns, so all this is just what I showed you. It returns the first few values of every vector. So if you look, if you, this function length of any data structure, it shows you the number of elements of that vector. So if you could use anything, as I told you like previously, you could use dim to find out the dimensions of any data structure, which gives you both the rows and the columns. But if you use length, it's only going to give you the number of columns or the number of vectors in any data any variable or data structure. Suppose if I have an x variable from with numbers 1 to 5, and I want to know what the length of x is. So that is 5, right? So x contains 1 to 5, and therefore the length of x is going to be 5. So we could find out the length of any vector by the function length. And there are different types of the vectors. The one example that we saw about the empty cars is that there is a numeric vector for every column. And similarly, we can have an integer vector which contains only integers. So if you remember in math, the integers are just the positive numbers, negative numbers, and the zeros. And numeric can be anything like decimals, positives, integers too, decimals or fractions, or anything like that. So this may be new to some people. It's a logical vector. A logical vector is generally it has just binary value, which is a true or a false. It contains only a true or a false. It's usually a result of any testing any conditions. So we'll come into this in the next few sessions, but I don't want to confuse you and overload you with information, everything today. There is another type of vector which is very common, is a character vector, and it has text in the text format. So dates and times. Date time is one class of the vector which has a formatted, dates and times as the month, day, month, year, or more such formats. We look at it at the end of the session. But we in everyday life we do not use dates that much. Times, yes, sometimes, but it depends on what field you are in. Maybe if you are in a field like finance or where the dates and times are very important, this might be something very important piece of vector class that you need to know and how to perform operations in that class. So factors, again, factors is a special vector. It has categories. So we will learn about factors in this session. Factors is very important. We try to use factors in pretty much every program we do. So this is something that you have to concentrate. Dates and times, not so much depending on your field. Dates and times might be important, but factors is pretty much used in every field. So we'll get to the factors a little later in this session. And if you want to know exactly what type of a vector it is, you could use this function is dot whatever. So here it is dot integer or is dot logical, different types. So is dot foo is whatever the type of vector you want to test. So is dot integer. So one example I want to show you over here is if you want to test if um, if one particular, say, empty cars column MPG, right? If I want to test if it is an integer, then it says false. If I want to test it if it is a numeric, it's going to give true because it is of the type numeric. So if you look at this, the empty cars structure, each of these columns is a numeric. So, and similarly, you have to know these types if you are not sure, because sometimes, so many times in practical sense, right? Some of the operations wouldn't work, and it is of the type character, although it's showing numbers, and that's why none of our code is working. So it's always a good idea to check what type of data structure we are dealing with so our operations work correctly. Okay, so let's go back to this. So this last part of the note, I just have it for more details for people who are interested. We really don't use this alphabet L. So what it says is to force as integers R does not really consider every number as an integer. It considers as a numeric, but it doesn't consider it as integer. So if you want to force a particular data type as a numeric or as a integer, you have to use the L, letter L after numeric. So this is not very important, but I have it as a note if people want to refer to it later on. So let's just go into how to create these vectors. So one example that we saw in the very first session of how to create vectors is by using the operator colon, right? So as I just showed you over here, I'm using a sequence of numbers from 1 through 5 to be stored in the letter X. So now X is a vector, right? So, and is it a numeric, or I could just see what the class of X is by using the class function. So I could just find, instead of testing if it is a numeric or an integer, by using as is dot integer is dot numeric, I could just say the class of X, and it's going to give me what type it is. So one other way of creating sequences of numbers, which is again, this is also another way of creating vectors. So the first way is, which you already know, is by using this operator, the colon operator, and the second way is by using the function seq, seq. So what it does is I could do two ways. So one is, as you know, 1:5, which gives 1:5, which gives the sequence of numbers from 1 to 5, and which is stored in X. So the other way of doing it is using the function seq, and there are three numbers that I need to give after this. I should give the number where to start from, where to end from, and how much it should step by. So the three numbers that I give in the function seq is the starting number, the ending number, and how much it should step by. So what happens if I give a 0.5? It's going to step by 0.5. So you have 1.0, 1.52, 2.53, and so on. So it's going to start at 1 and end at 5, and it's going to step by a 0.5. So this is the way of creating another way of creating vectors by using the function seek. And there is another way. You really do not need to use this one. It's actually a much more verbal way of doing it. Like seek, from equals x, 2 equals the second number, and length dot out, or you could use by equals. But simply, if you just remember, seek three numbers, what they mean: the start of the sequence, the ending number of the sequence, and how much to step by. That will be enough. And another way to create the same thing is by using the function rep. It repeats how many times you will have to use a particular number. Suppose if I use a vector, so suppose if I want to create a vector of, say, 1, 2, 3, 4, 5 times, right? So you get this, right? So if I want to print it out 5 times and create that as a vector, I'm going to give whatever vector. So this we learned in the very first class. If you use C, you combine all those values that are given within the parenthesis after C into one. You combine it into one vector or one string. So what we are saying here is repeat whatever I gave you before the comma, repeated that many number of times. So if we go back to our slides, that's what it says. Whatever you give in the C, you could repeat that many times. And the next one is pretty much the same. So you could try one of this. Just do it in your R Studio. Just type one of this. Just type the seek of 1 to 5, 1, 5, 1, 5, comma 1. Just type this and see what it gives. You could try 1 colon 5. It's going to give you a 1 to 5 sequence, and you could do it the same way as sequence 1 comma 5 comma 1, which is going to step by 1. Or you could try this. Try one of this right now. I'm just going to give you a couple of seconds to do that. Everybody with me? Did you try? Okay, good. All right. So So, so the next one is to know the index of each of these numbers, right? So whenever you type a vector, it's actually going to a vector is going to keep an account of where the integer is. Suppose here is an example: numbers equals 30 to 1. So it's going to go backward, right, from 30 to 1. So if you look at my console over here, and I'm going to do x's 30 to 1. If I get my size a little smaller and try to type x. So if you notice, there are 2 lines here, and at the start of every line there is something in square brackets. That's the starting index of the very first number, and the second line has a number 23 within the square brackets. That is the starting index of the second line of number. So what this means is 8, the value 8 is at the 23rd position in this vector x. So if you want to retrieve, suppose if I want to retrieve the first value from this x, I don't want a whole series of values from 30 to 1, but what I want is just the first value. You could use the square brackets and put a value in that. So what I'm doing over here, if you notice, x square bracket 1 is going to retrieve the very first value in that vector x. And if I want the 23rd value, I type in 23rd right after x, and it's going to retrieve the 23rd index of the vector x. Okay, and if I want to know the length of x, again this one we did earlier, that is 30. So what is the 30th value? If I want to look for the 30th value, it's going to be 1. Likewise, you can retrieve any value by using the square brackets right beside the vector name. You could use the square brackets and the index of the number you want. So usually in practice, what we do is every bit of what I'm teaching you here, we will use it in a form that's useful for programming. What we do generally is use a variable, maybe I that will loop through 1 to 30, and then we use it as x of I within a loop. So x of I goes from 1 to 30, and within a loop, right now I'm not going into details of what loop means, but it means that you circle through that particular vector and retrieve each and every values from that vector. So it will loop through this. When the value is 1, it gets the first value. When the value is 5, it gets the 5th value, and so on and so forth. So everybody following till here? Any questions you have? Any questions, guys? Okay. So everything is clear till now, right? Okay. So let's go on to our next slide. So changing values in a vector, this is something very frequently that we need to do. So what do we do? How do we change this value? So in our example, suppose I want to change, I don't want 1 to 30 or 30 to 1. I want say I want to change the 5th value or whatever it is. What I do, how to retrieve the 5th value again, x of 5 is a number is the number 26. I don't want the value 26. I want to set the value 26 to 0. Suppose if I want to do that, what I do is x bracket the index of the number that you want to change and set it to 0. Okay, now if you print x, that 5th value of 26 is going to be set to 0. So similarly, what if I want to set multiple values to 0, right? So I don't want anything from 5th position to 30th position. I want to set them all to 0. So what happens if I do this? So everything after 5th to the end of the vector is set to 0. So this is the way how you can change. Suppose if you just want to change a couple of values, a couple of indices, you want to set it to 0. You could just do C of and give the index. If I want to do 1 and 3 to 0, this is what I do. Now type x, 1 and 3 are set to 0. So this is the index of that particular vector. So you could use anything as an index. You could use one single number. You could use a sequence of indices. You could use maybe a couple or even more by using the letter C. This is one way of changing the vectors, the values in the vector. And again, I have this over here. that says nervous about making mistakes. Which is always the case when you're a beginner programmer, where you don't want to lose any data. So what you do then is you always copy that vector into some other vector. Suppose if I don't want to mess with X, what I do is I copy it into Y, make a backup of it, and then change X. Or I could copy it, I could make a copy and change Y and keep X as it is. So either way, you could just create a copy of it and save that vector. Don't do any manipulations to it, and use this temporary vector that you copied into as a point of manipulation or testing your code. Um, so I have a question here. Can X set back to, can X of 5 to 30 set back to consecutive numbers as well? So consecutive numbers, if you want to set it back, Monica, you'll have to have it the way initially the vector is made. So initially what I had is X 1 to 30, right? And then if I want to change it to 5 to 30, so your question is 5 to 30. If I set it to 0, and if I want to change it back to those numbers, right? Then you'll have to. So right now, from 26 is 0, right? So the way you could do it is 5 to 30. You could set it back from 26 to 1. So that way, from the number 26, it's actually there. So you'll have multiple ways of doing it. Once you start experimenting with it, I did it this way, but you all may get creative. You could use a different way. So this is just one way of doing it, and yeah, there are many other ways. Once you start experimenting with these commands, you could come up with different ways of doing it. So that's about changing values in a vector. And you have many vector operations. There are on the whole vector that you could do. You could do a sum of that vector. You could do a product of the vector. You could do a minimum, maximum, cumulative sum. So I'm just going to show you what a sum and a cumulative sum means and how is it different. So right now, X has the values from 30 to 1, right? And if I want a sum of sorry, if I want a sum of that vector, I'm going to use the function sum of X, and it's going to calculate, just add up all the values present in the X. But if I do a cumulative sum of X, it's going to add the previous numbers until that position. What I mean by that, the first number is 30. The second number is going to be 30 plus 29. The third number is going to be 30 plus 29 plus 28. So whatever position you are in the vector, it's going to add that particular position plus everything that precedes that position. So a cumulative sum is this is what it means. So let's just do 1 to 5 so you follow it properly. So right now X is 1, 2, 3, 4, 5, and sum of X is just an addition, simple addition of everything in X, and a cumulative sum of X is a cumulative sum, meaning 1 and then it adds 1 plus 2 and then it adds 1 plus 2 plus 3 and so on and so forth. So similarly, cumulative product, cumulative minimum, cumulative maximum, each one of these means it until that position. Suppose it is cumulative minimum, right? Cumulative minimum means whatever the minimum number value there is until that position, from the start to that position. So similarly, cumulative product. So you can try out all these and try to do just try one of it. I want you to try just the cumulative sum of x by assign x as 1 to 5 or anything you like. Just try the cumulative sum of x. Right now, do it, guys. Okay, so you got the general idea of what vector operations means, right? And right after this, I'm going to talk about just one more important thing, and we'll wrap the session for today, and we'll continue next time from this particular slide. But I want to just introduce you to this concept of factors. So when sometimes we have we have certain levels or certain levels within a vector. It's not just numeric or just a character vector. It means there are certain levels, and I'll give you examples of this. So one such example is the directions of northeast, southwest. So these are different levels or different labels for directions, right? There is a way in R to create these factors and label them appropriately. And for example, this is one such example where we have the directions as northeast, southwest, and you are creating a factor of that. So so basically in R, the way to categorize data, and one such data structure for categorical data is factors. So we could create factors using this. I just want you to I want to just introduce this concept right now, but we'll follow it on, pick it up on in the next session. But so far we have covered what vectors do in this session, what vectors do, what those operations are on the vectors, and what functions are used on vectors. And we covered some from the previous class of just having the minimum, maximum, mean, standard deviation of any particular structure, and we saw the structure, how to use str function for any data structure. And we saw different types of vectors, and we also saw how to use the help in RStudio to look up any documentation regarding any functions, just the usage of it, the arguments, and things like this, and the examples. So I hope you have learned something in today's session. I'm going to share these slides with you, and if you are interested, you could go through the next set of slides, which is the slide number 11 through 20, but I will cover that in the next class. And I have a few new students in this class, so I urge you to go through the very first session. It's very important if you're new to R programming, very important to go through that session, practice some of the examples that we have gone through in session 1, and you could practice this session too. So right after this, I'm going to share these slides with you, and the video uploading will take some time. So I will share it with you whenever it's available. So any questions for today's session, guys? Any questions, please type into the chat window. Okay, so if you have no other questions, you can always, oh, just 1 second, I have some questions coming up. So few other data sets, right? So there are a lot of data sets. Like so Venkat, I will actually email you some of the free data sets that are available with that R ships with, and you could just try these commands on it. That's a very good point. Thanks, Venkat. So large data sets. So one question I have is small data sets can be seen on console, but how to see large data sets? Large data sets, Dr. Priyatam, large data sets, we cannot see the whole data set. So one way of looking at them is just the top few lines. It can be looked at, or you could try to open it in the viewer over here. It's going to open up only a certain number of lines, maybe up to a top thousand or so. So you could look at the structure of the data set. You cannot look at the full. Unfortunately, there's no way to look at the full data set if it is a large data set. And the way R handles it is to convert it into compressed formats. So we have different formats to handle large data set, in a compressed R data format, RD format, just to load that whole data set. But there is no way to simultaneously or display the whole data set and look at it. Yes. Yeah, so yeah, there is no way to look at the whole data set. If it doesn't fit in RAM, suppose if you're looking at a two gigabyte file, you cannot look at it all at the same time, not in R. Okay, guys, so I will send everybody a list of the free data sets that are available in R right after the session, and I'm going to send you the slides for today's session, and the recording. I will upload it and provide it to you in a day or two. Thank you, everybody, and good night. Thank you for joining in today.